advanced pre-calc topics, we'll actually be doing this often, and it will have more meaning to it. There'll be some stuff behind why we're doing it, but for now we're just practicing the algebra. So back up here, that's the f of x we're working with. This wants us to do f of x plus h, and then subtract f of x and divide everything by h. So let's back up. If it asked you to do f of 5, what would you do with this?
Plug a 5 into x.
Plug a 5 into x, right? Well, if they're asking you to do f of x plus h, then you're plugging what in for x?
H.
Nope. F of h would mean
X
plug in
plus
h.
h.
We're actually plugging in the entire x plus h for x. So f of x plus h is just going up here and plugging in x plus h for the x. Keeping in mind there's two x's up there, right? So there's two different places we're plugging in an x plus h. 2 parentheses x plus h squared minus 3 times x plus h. And put brackets around that, because that'll kind of group the first part together. That's what f of x plus h is. It's plugging in x plus h.
It's feet per second squared.
Yeah, I know. But where does it come from?
Yeah,
Like negative 16.
because instead of 9.81 meters per second squared, it's 16.4 meters per second squared. So math just uses 16 meters per second squared.
Right, because
That's
that problem was in feet.
Yeah.
Yeah, because when our problems are in meters, it is negative 9.8.
Yeah.
But the acceleration due to gravity is negative 32 feet. So why is
Yeah,
it half of
but
that?
Meters per second squared. So it would be 16 instead of 32. Or at least that's what Mr. Crow just told me. So.
Did he talk about the 32?
No.
Go ask him why it's 16, which is half of the 32. The acceleration due to gravity in feet is negative 32.
Okay, I'll be back in 1 minute.
Find out why it's half. Sorry. I told him you guys wouldn't mind the disruption.
I'm pissed.
Connor, watch your language.
What do you mean?
That's not okay in my class.
Pissed?
Yes. All right. Enough. It's all on
I'm
video.
not gonna have that.
This is all on
That's
video.
not okay. That's fine. No
So-
one's gonna say pissed.
Get more YouTube views, clickbait.
I'm going to tell you right now.
What's your go to get pissed? You tell me what your go to get pissed. I'm gonna say.
Okay, let's back up. I'm going to tell you, stop using the word, or else we'll just call it insubordination because you keep using it despite me telling you not to.
Okay, but explain to me why I can't use it.
Because it's a swear word where I grew up.
Ooh.
It's not the worst one, we all know, but where I grew up, it's not okay.
I might, honestly, that's kind of fun.
And this is my classroom, you're just living in it.
YouTube.
He doesn't like that, he doesn't like rules. Yeah, John.
So the formula is
I
distance
hate being
equals
back
1/2
stage.
AT squared.
Oh, 1/2 AT, so it is half of it. 2 points for you, John. You're the man.
Thank you.
All right. So now that's my first part. Minus f of x. Now here you really don't need to do much. F of x was given to us. We just have to subtract the equation, 2x squared minus 3x. So here's f of x plus h with the x plus h plugged in, minus f of x as is, all over h, and we just have to simplify this. Are you ready for that? It's not bad. It looks worse than it is. First thing you have to do is square out your x plus h. Now whenever you square out x plus h, it's always going to be the same thing, and the more you do it, the quicker you'll get at it. But for now, if you want to square that out, obviously the 2's out in front, but that's an x squared plus an xh plus an hx, which I'll just write as xh, because the order doesn't really matter there, and I just want it to look like the previous one. And then plus an h squared. So when all's said and done, that piece is going to be just x squared plus 2 of these xh's plus h squared. And I'll distribute that 2 later. I can distribute my negative 3 right now. Minus 3x minus 3h. And I can distribute my negative sign right now. So minus 2x squared plus 3x all over h. Now, because I'm running out of room, and I don't like to write more than I have to, I'm going to kind of combine the next two steps, which is going to be distributing the 2 and combining like terms. If you don't want to do that all at once, you don't have to, but I'm just running out of room. So 2x squared, are there any other x squared terms? A minus 2x squared. So a positive 2x squared and a minus 2x squared is actually going to cancel that out, yes? I'm not crossing out the 2 just yet because I have to keep distributing it through. So far, so good? Then we have a 4xh. Are there any other xh terms? No, so that's just 4xh. There's h terms, there are x terms, but there's no xh terms other than that one. And then I have plus a 2h squared. Any other h squared terms up top? So I'm done with that too. Now minus 3x, any other x terms up top? Yeah, minus 3x plus 3x will cancel. And then I just have a minus 3h. Now, what just happened will and should always happen. So I'm going to tell you what it is in a second. But if this doesn't happen, you probably made a mistake. So stop right here.
So you just leave it over h?
No, not yet.
Okay.
When I simplified the top, what now do all of the remaining terms have in it? An h. And that should always happen. If you have a plain x term up top, you probably did something wrong. Okay? Because all 3 of those terms, the fact that they all have an h, means I can divide an h out of all of them, right? Because I'm technically taking a GCF of h out in front, and then I'll cross it off. Does that make sense? So I'm not going to show taking out a GCF of h. Just since every term has an h, they each can be divided by h. So now I'll have 4x plus 2h minus 3. And that's my answer. Does that make sense? Any questions on that? Because I think it's a better use of our time, since I think a lot of you know how to do this, I'm going to give you a minute on the bottom of the back side of these notes. I'll just have you do, let's do this one. You know what, we're going to do this together because it's slightly different. There's our function. And again, this right here, and this whole section on your homework is on it. That's the same. We're going to do that for, all of these. So f of x plus h, what will that look like? When I plug x plus h into this, Carolina, what's it going to say?
You would still be the radical x plus 1 and then xh.
I'm replacing this.
It'd be h minus 1.
Nope. I'm replacing this with x plus h. So just take that out, put an x plus h in there for it, and then just copy everything else down the way it is. Does that make sense? So there's your f of x plus h. That was actually easier to plug in, right, than the previous one. Minus your f of x, just copy down the function. I don't really need the brackets here. They're not really doing much, but since I used them last time, I'm just using them again. All over h. So unlike the other one, which it was pretty obvious what to do to simplify, this one it's not as obvious. But this is where we're going to take one of the skills that we learned earlier in the year and put it to use. Does anybody remember what we would do to something like this to quote-unquote simplify it?
Multiply the h over first so that you can square the right side.
Say that again?
Couldn't you just multiply the h over to the left side so that would be h equals the radical side, and then you can just square the radical side?
Well, there is no left side. We're doing, the left side is just this, f of x plus h minus f of x all over h, and we just want to simplify this. So we're just looking for like the next cleanup step. And this was brand new to you then, but we're going to review it now, was rationalizing the numerator. Remember when we did that? Remember that? Did we do that?
You multiply it by like
Yeah.
the same thing it is.
Because we always, throughout Algebra 2, we rationalize the denominator. The idea, though, with this whole thing is to get rid of the h on the denominator. And you'll see why, again, when we get to this in like the more calc end of pre-calc. We need that h to get rid of itself. And so the only thing we can really even attempt to do here is rationalize the numerator. And truly, this is the kind of scenario that kind of justifies why we even did that skill to begin with. So you'll see, what is the conjugate of the numerator? Tommy?
Like the whole thing or just
The whole thing. This is a binomial, right? Something minus something. So what's the conjugate?
that first part plus the.
Right. We're going to keep it x plus h minus 1, but now it's going to be plus the root x minus 1 on both the numerator and the denominator. The denominator part we don't actually multiply out. You just multiply out the conjugate. So if I throw some parentheses around this and I start foiling, what is the first times the first? If you multiply a radical by itself,
H minus 1.
right, you just lose the radical. So that's just x plus h minus 1. What's the wonderful thing about conjugates when you multiply them?
There's no middle part.
The outer and the inner cancel, so just essentially do that, but don't write anything down, because it'll be a positive whatever and a negative whatever, and they'll cancel. And then your last times your last. First of all, it's a negative times a positive, so that's going to be a negative. This is where you really got to be careful. Because it's a negative, and what is root x minus 1 times root x minus 1?
X minus 1.
And that's a binomial. You're subtracting a binomial. So you need to keep that x minus 1 in parentheses. And then on your denominator, we're not multiplying anything out. We're just keeping that h out in front of the parentheses. Remember, what is our goal? To get that h to cancel. So when we simplify this numerator, you have to distribute your minus sign, but it's going to be x minus this x, which is going to cancel. It's going to be negative 1 minus a negative 1, which is going to cancel. And what's your numerator?
H.
H over h times some crazy parentheses. And our mission is accomplished because now that h from the denominator is going to cancel. So we just have 1 over crazy radicals. Yep.
I thought we could have radicals in the denominator.
You know what? Once you get to calculus, that whole rule is like not a thing. Sorry. I can't remember the logic behind why you can't have radicals to begin with in lower level maths. I think it's got something to do with the fact that people didn't used to have a calculator in the Greek times. I'm serious, I've looked this up before. Stop laughing at me. Do you know why it is?
I want to say it was something with measurements, wasn't it?
Maybe. Back when they
Yeah,
like,
I think it was something with measurements back.
yeah, back in the day, like BC times.
Yeah.
So it's just something that math just still says, like you can't have a radical in the denominator, but once you get to upper level math, that just like doesn't matter anymore. We forget about it. I don't make the rules, I just teach the rules.
So then
Okay.
why do we learn it?
I don't know. I don't know why they don't get rid of it. I think if you ask Mrs. Hill, she might say, I don't know, they should, but they don't. Rationalizing is still a thing. I don't know. But anyway, that's the final answer. We're done. So great question, Lydia. Sorry you were wasting your time in Algebra 2. The good news is that helped you practice getting rationalizing period, which you definitely do have to rationalize numerators to sort of get this h to cancel out, but we got it. All right, so really quickly up on top, domain, we'll just go around the room. Tori, what's the domain of this picture? Interval notation would be good.
-3 to 6 bracket.
Anybody disagree? Good. What is the range? Sarah.
Parentheses -4 to 4 with the bracket.
Anybody disagree? Good. F of 6. Madeline. Where the x, look on your graph where the x coordinate is 6. And tell me what the y coordinate is at that point. 1. So f of 6 is 1. I don't know if you guys have this ever pointed out to you, but this notation is no different than 6 comma 1 was way back when you first started graphing points. F of -2, Ryan?
0.
Good. F of 4, Faith?
-1.
Okay, so here's a different question. For what values of x does f of x equal 4? So they're essentially saying, for what values of x does y equal 4? Right? That's the same thing? Who can tell me what those are? Those are, I don't know how many. Lydia, go ahead. There's only one of them, right? Y equals 4 is right here. So what is that x value? 1. And that's why you see that S in parentheses. What value or values, because there can be multiples. And number 7, Mike.
-2, 3, and 5.
-2, 3, and 5. Good. Oh, good. Part B is a step function again. You loved these. Doming. Go ahead, Carolina.
Probably very wrong, but would it be bracket -3 and then bracket -0 parentheses?
Oops, 0 parentheses. Anybody disagree? Carolina, you have the support of your classmates. So that's the good news.
And wrong then.
The other piece of good news is that you are correct.
Oh, okay, cool.
I'm glad Ryan thought that was funny. Range might be a little bit tougher. Where's my all-star that can tell me the range? Come on. Oh, you know why? Oh, go ahead, Andrew.
Bracket -3, 1 bracket.
Bracket -3,
Only for certain values or something.
-1 bracket, you said?
Yeah. I don't know where the trick.
So when you use interval notation, does anybody want to correct that? Faith?
Wouldn't it be parentheses because they're both open circles? So it's not including the -3 or the negative.
Well, does this graph ever reach -3?
Yes.
It does.
Oh,
Does it ever reach -1? It does. Yes, there's an endpoint that's open at one location, but that's for a different reason. It does actually, there are points that you could find that actually have a y coordinate of -1. Laura, I feel like you could pull this one off. She's so quiet back there. She's like the silent killer back there. She always does great, but she doesn't ever talk to me. So talk to me. What do you think? That is not right. No.
It's not right.
do you do it?
Do you do like a what? Take a stab at it. You want me to come look at what you just wrote down? See, I told you she knew. She got it. This is what she wrote down. Good.
That's what I was thinking.
And why does it have to be written that way and can't be written that way?
Because it's a piecewise.
That's not necessarily the reason.
You have to include every separate range.
Well, this one includes stuff that it shouldn't. From -3 to -1, written in interval notation, is a continuation, which means based on this notation, you think it includes everything from -3 up to -1 and everything in between, which is just not true. It doesn't actually reach -2.5. If you look at where y would equal -2.5, there is no x value that would go with that. So this is a finite list. It only hits 3 y values, -3, -2, -1. It's not a continuation, which does play into your pieces, Lydia, a little bit. It's not a continuation where it hits everything in between. It skips sections. So we would write that as a list. Are we good with that? Okay. How about f of -3, Allie? -3, good. How about f of -1, Alyssa? If you look at an x value of -1, look up here. Where is the y coordinate of that point? -1, yeah? What was confusing you? The fact there are 2 points there? But one's open, one's closed. So you definitely want to take the closed. Does that make sense? Good. Because an open circle is not actually a point. All that is, and I know you missed this on Friday, but you are going to equal a y value of -2 from an x value of -2 all the way up to, but not including -1. So -1.00001 would still have a y coordinate of -2, but as soon as you hit -1 as your x coordinate, it jumps to the next step. And that's kind of why it's called the step function. And Connor, for what value of x is f of x equal -2?
-2.
There's more. -2, because here's our y equals -2. So our x values are at -2 up until, but not including -1.
Oh, I didn't know.
A little bit, definitely trickier with a piecewise. Or with a.
wrote that on my paper and I crossed out the -1 before.
Yeah, but it's actually equaling -2 for that entire stretch. Up to, but not including -1. Okie doke? So, like I said, I probably should have changed your homework a little bit for Friday. This kind of goes in line with what we just did. So if we already did that, you already did it. So your only homework is here in the odds. Okie doke?
I'm still so upset I can't say the word.
What's that?
I'm so upset I can't say that word. I don't understand your problem with that. Like, why does this still bother you now?
You know what? If we were like hanging out